Okay, there we go. All right, let's get started. So, everybody who teaches in this room should have the microphone volume at exactly the level I like it at. That should be the rule. All right, let's get started. So, OAuth slides, I updated these this morning. You might have to refresh the page to get the latest slides. So make sure you refresh it, because I did rename the file, the PDF file name itself. So you have to refresh, make sure you get the new link, and it should be 2_9 OAuth. So just in case your slides are looking different than mine, they are posted, but you have to make sure you refresh to grab them. Okay, and let's do it. Any questions before we get into it? And well, let me set the stage at least. So last week we did everything that you need for the 3 LOs, the learning objectives for homework 2, and this whole week we're doing the 2 AOs. So this 2-week chunk of content for homework 2 is evenly split between LOs last week, AOs this week. So if you're, make whatever decisions you're going to make with that. If you're only aiming for learning objectives, this is a pretty chill week for you. If you're aiming for the AOs, you definitely have to pay attention this week. The outline for this week, today I'm going to introduce what OAuth 2.0 is with, as it says, an overview of what it actually is and why we use it. On Wednesday, I'm going to go over a lot of the details of exactly how what we talk about today works. And then Friday, I'll talk about some extra, bonus features that we can add on to OAuth 2.0 that you'll see out there in the wild. So any questions before we get into it? Do I give partial credit for AOs? I mean, yes and no. Mostly no. If you get a 2 on an AO, you still get credit for it. So I don't give partial credit, but I do give full credit even if you have some small mistakes. So if you get a 2 out of 3 on an AO, you get full credit for that AO. But once if you get a 1 or a 0 on an AO, for the submission this morning, if you got a 0 or a 1 on any of those AOs, you get no credit and there's no extra chance for it. And the idea of that is you have to, at this level, you need to be able to test your own code. You should be testing it, making sure, just go through the testing procedures yourself. Did I don't know if I went through this maybe on day 1, but I don't think I've gone through this again now that it's relevant. The testing procedures that I put in the homework, that's the same exact stuff I give the TAs. I don't have a separate grading document that I give the TAs. They go through those exact testing procedures. So if you follow my recommendation that I put in the big, I think, red text box in the homework documents, or yellow maybe, I don't care, whatever color it is. After you submit, download your zip file and just pretend you're the TA. Download your zip, extract it into a fresh directory, Docker compose up, and go through step by step exactly what the TA is going to do. If that works, everything works on your app, you can be reasonably assured that it's going to work when the TAs run it as well. I say reasonably assured because some students write, I'll word this a little more delicately. I was going to be more blunt about it. But some students write code where it only works in their specific environment. One of the most egregious examples, which hopefully I don't see at all this semester because I restructured LO1 on homework 1, is their browser would always send the headers in an exact order. So they would get the request, split on /r/n, and then to get the cookies, they would say, get me, after splitting on /r/n, that array, or Python, so list that's returned, give me the value at index 17, because that's where the cookies header is in their one browser that they tested in. That code's going to break when the TAs grade that. So I say reasonably assured. It will work the same way that the TA is going to grade it, unless you do something silly like that, where you absolutely hard-coded to just your browser. And even then, if you test in, the TAs will test in Firefox and Chrome. If you test in Firefox and Chrome, you'll usually find those bugs when you write your code testing with one environment and then switch to the other browser for testing after you wrote all your code. You'll usually find any of those bugs that the TAs will find. So as long as you have good testing practices, you can be reasonably assured. So there's no really need for partial credit or second chances for the AOs. I do for the LOs just because the stakes are so high, but there's no reason to give you a second chance on AOs. Like, do the work, test it. If it pass your testing procedures when you ran it, TA is going to do the same exact thing, should pass when they do it. For what it's worth, this is a little behind-the-scenes stuff you don't necessarily have to care about. But whenever you get a 0 or a 1, well, not a 0, because 0 means you didn't even try to finish it. But whenever you get a 1 on an objective, a second TA will regrade it automatically. So we always have 2 sets of eyes before you lose credit for an objective. So we try to make sure there's no grading mistakes on the back end. Sometimes there still are, and then I address those ones. But for some reason, Favicon didn't work no matter what. I don't know what to tell you at this point. Yeah, I have a recopy of the given HTML code, and it worked for me. I have a I'm glad it worked for you. I don't really understand what you're saying, though. What would be the best way to test Homework 1 AO2? So that one does get a little tricky. The AOs the AOs usually have something where you have to be a little creative, actually take everything we've learned in class and combine it. For testing AO2 on Homework 1, my intent, my expected strategy that I would expect a student working on the AOs to find would be to look at my AJAX code that makes a post request for chat messages and change post to put. And then use that code as your testing code to be able to send put requests and test the put path. And then delete, you click the X's next to the chat messages. That one should be pretty straightforward. But the put requests, make an AJAX request and change post to put. We covered AJAX, and for the LOs, I didn't require you to do any AJAX. But for an AO, you should be responsible for all of the material we cover in class. Not just take my front end blindly, but actually understand how it works to the point that you can modify it for additional needs. And that was one of the tricky things, one of the intended things of AO2 was how do I test that put request? Okay. Anything else? We just had our first deadline. It's a big day. Ooh. Okay. And I don't have, we obviously didn't grade everything yet, so I don't have too many stats, but the one that's so frustrating already, probably not speaking to anybody in the room, I assume, but 24 students out of 240, so 10% of the class, did not even submit Homework 1. No submission at all. I don't even know what to do with students like that. Like, what could I do at that point when you don't even bother submitting? It's crazy. So every one of you is at least you're at least in the top 90%, just if you made a submission, which, and Postman kind of changed the way they do things. You have to store everything on their servers and create an account and everything, so I shy away from them a little bit, but Postman is a way to test, or you can manually send your HTTP requests using Python code. You can do some testing. We'll have a lecture later on in the semester where we do that, but we got to get into some OAuth stuff. Okay. So Web API, we have quite a bit of background today just to figure out why we even need OAuth 2.0. So let's do some background, and eventually, about halfway through these slides, we'll finally get to OAuth 2.0. First, a Web API. We talked about these before. We had our RESTful API, and we had our our HTTP requests mapping to CRUD operations on our database. And our users can interact with that, and we use that for chat messages. That was an API. In general, it's a way for our users to interact with our server without necessarily using our front end. So our API that we built was consumed by the app itself. So the app is making API calls to the back end, and the back end happens to be in the form of an API, and we built the front end so users have a nice, convenient way with a nice UX. Well, debatably for the homework, I just built something for the front end so we can test it. But you'll build a nice UX on the front end so they can interact with your API. Or the bigger advantage, in my opinion, is to allow users to connect to the API directly. They can write code, custom app, custom front ends, whatever they want, and connect directly to the front end. This is a really nice feature for developers like us. We can develop third-party, eventually what we're going to talk about is we can develop third-party apps that other people use that connects to a separate API, which gets really interesting. We can do a lot of stuff with that. It gives us a lot of power. So we're writing code that's going to interact directly with the API through HTTP requests and completely ignore the front end. And when we start doing things like this, it really becomes apparent why we don't trust any front end. There is zero front end security. There's no such thing as front end security. Because even if you're not hosting an API, users can write their own custom code that connects to your HTTP server directly. There's no need for them to use your front end at all. They're just going to build their custom app that pretends to be a front end, and your server isn't going to be able to know the difference because we just don't have any mechanism to do that. Any mechanisms that we have in place to be able to detect that, the attacker's going to spoof. Like anybody writing code, sending their custom HTTP requests, like they can literally, just like when you're sending your responses from the server, they can literally type whatever they want. Any byte sequence ever, they can send. So they're going to spoof absolutely everything. There's really no stopping it. Okay. So the way this can work and the way it used to work in the end is to access these endpoints. We'll have paths. We'll have documented paths. Any API you go to will say, here are the what we call endpoints. I use that word quite a bit, even in lecture. I haven't really defined it, but this is the definition. Any method path combination that's going to be an endpoint that users can access to interact with your server. And any of these endpoints, we're going to hit to do whatever we want. We'll use the Spotify API in the homework. I use it to start and stop the music at the beginning and end of lecture. I have software that I'm running. It's running right now that's waiting for the end of lecture, and it's going to send a message, send an HTTP request to this Spotify. I don't have it. Oh, yeah, I do have it up there. That put Spotify.com v1 me player play. That's going to start the music. My code is going to send a request to that endpoint at 2:48 p.m. today. So we can write code that interacts with the API by hitting the endpoints. And the way this used to work is by getting an API key, which is kind of outdated now. So there's a few ways that this could work. Whenever the user wants to connect to the API, send username and password. We don't want to do that. That's why we have auth tokens, so users don't have to do that. So we can use the auth token directly, but that's bad. That's bad. I have to justify that a little bit. So that's bad. To just use the auth token is a user connects to the API, uses the auth token. For some purposes, that's fine. For our chat messages, that's fine when it's our front end and they're using our app. But the auth tokens weren't really designed for API access specifically. And one of the big things here is that the auth token has all of the permissions of the user. If you have that auth token, you are the user. You can do whatever that user can do. And sometimes we want a limited access. We'll issue what's called an API key, and then that key, which will look similar to an auth token, is just a big, long, random thing. And that API key is going to be used to access the API for a few reasons. One, if somebody compromises that API key, it's only for API access, and it can even be issued for a limited scope of the API. I can get an API key that's only valid for a few of the endpoints, just the endpoints I need. If somebody compromises it, they can access those endpoints, but they can't, say, change my password. We have other protections in place for change of password, usually email verification these days, so they wouldn't be able to do it anyway in most apps, but they could do a lot of damage if they have the auth token, but less damage if they have an API key, and these API keys are easy to revoke. If I want to revoke an API key, the API key is just revoked, and I can still be logged into the app, and I don't have it on the slide here, but you can also get an API key, share it with somebody else, and give them the authorization to, I have it implied, but authorization to use the API on your behalf. So I can give somebody my token or my API key without giving them my authorization token, so they can't be me. The auth token says I am me, but the API key says I have authorization to access this API endpoint. So they are a little bit more shareable. Obviously, you have to be very careful with who you share it with, and that's kind of one of the problems OAuth is going to solve is how do we share these things? And the way this works, this is the way things used to work on the internet, as I said. You'll register, log in. We talked about that all last week. Hopefully, we're all good on that. Get an auth token. That auth token is going to say, I am me. Don't ask me for my username and password again. If I have this token, I am me. We're going to use that token to request an API key. The server is going to look at our auth token, say, yep, you are the owner of this account. Here's your API key, valid for this account. And then I'm going to access the endpoints by sending that API key. The server checks the API key, much like it would an auth token. Check the API key, check whom it issued this API key to, look up that username, and then say, okay, you have authorization to access this endpoint with this account's permissions, and then respond with that private data. This was the good old days. I say this is the way it used to work. Sometimes I wish it worked like this still. Most APIs don't do this anymore because they'll use OAuth 2.0. But this is a nice simplified view of how we want to do this. I recommend the Python request. I also recommend the Python requests library. Oh, you're talking about testing AO2 still. Yeah, if you're sending custom requests for AO2 and not using Ajax in JavaScript, the requests library, easiest way to do it. If you're not using a separate tool. If you're writing custom code, I would use requests as well. Whenever I use Postman, my website endlessly buffers. That's the other reason. So I used to cover Postman in class and say, everybody use Postman to test your API endpoints. And that happened all the time. The number of office hour questions of Postman is endlessly buffering, what do I do? Because when Postman puts a lot of faith in you, and if you have one character wrong anywhere in your response, it'll just not do anything. It has a parsing error somewhere. There's an error somewhere in Postman, but it won't tell you what that error is, and it's really frustrating when you're coding at this low of a level where you're handling all of the low-level details manually. It is very difficult to get information out of it. Why is sharing your auth token bad? Oh my. I feel like I failed you last week. I feel like I failed to explain it if you're asking that question. An auth token, they have your account. Like if somebody has your auth token, we did a whole cookie stealing demo on that to steal an auth token. If you give someone your auth token, they own your account. They have your account. What is an API endpoint? Any method path combination is an API endpoint. And in general, just endpoints, just web endpoints. Git / is one of your endpoints that serves up your index.html. That's an endpoint. So API endpoints, they come in different varieties, but these are all endpoints. Like the play endpoint, if I want to start my Spotify playback, it's a put at that URL, and that's going to start my playback. Yeah, nothing bad will come of it, but please don't paste your auth code in chat. That would be bad. Can anyone get an API key? If your API works this way. So the API has to support this. For example, the homework API, if you did AOs 1 and 2 on homework 1, there's nothing in there where we said support API keys. So the API does have to support API keys. Most APIs do not do this anymore, which is why we have to talk about OAuth. So this works. Like, give me an access token, and then let's access the API using that access token. So why even talk about OAuth? I'm always going to talk about OAuth 2.0, by the way, but sometimes I leave off. Like on this slide, I leave off the 2.0. 1.0 is pretty much dead. Everybody uses 2.0. It's the successor of 1.0. intended to completely replace 1.0. So where does OAuth come in? So here's the problem that OAuth is going to eventually solve. And you would get an API key for your account. It would be just like your auth token. It's associated with your account. So anyone can get an API key for their account if the API supports API keys. So here's the problem. We want to access an API on behalf of our users in a secure way. How do we access an API on behalf of our users, have our app access an API on behalf of our users in a secure way? So we have code. A user wants to go through our code and access a third-party API, and we're going to access it on their behalf. How do we do that? And we use this a lot. Whenever you've seen a sign up with X button on any app ever, log in with Google, log in with Facebook, sign up with GitHub, that's OAuth 2.0 in action. So how do we build something like this? How do we build an app that's going to be a Scrum board app that's going to be able to create an update? Oh, I got an S there. Oh, creates. Oh, that's right. Create and update GitHub issues for your users. So somebody goes to your app and they create an issue in the. They create a card on the Scrum board, and you want that to automatically create an issue in the GitHub repo for that Scrum board. How would you do that? Well, your app is going to make a third-party request to the GitHub API on behalf of your user. Did I say that enough times? I think that's 4 times. Making requests on behalf of your users in a secure way. Okay. So how do we do this? Because this happens a lot out there. There's a lot of times you use an app that's going to interact with another service like this. So how do we do this in a secure way? So let's talk about a few bad ideas. Because we want to do this securely. Because we can do this. Like just with what we've covered last week, we can do this. We have a variety of mechanisms to be able to do this. We can do this. First, terrible idea. You want to create this Scrum board and create issues, GitHub issues for your clients' repos or your users' repos on their behalf. First, terrible idea. Just say, hey man, I need your GitHub username and password. Hopefully it's self-evident why this one's so bad, but just in case, you're handling their username and password. They're giving you a lot of trust, and then you're logging in as that user. And now if the user wants to use that API again, they want to create an issue. Okay, now they want to create a second issue. They have to give you username and password again. We still have that issue. And now we're constantly communicating username and password over the internet, or we store their username and password, which would have to be in plain text in this use case because we need to go back to the original password so we can keep sending the plain text password to GitHub. So we would have to store a plain text password. Awful. I don't have a slide for it, but we could also store their auth token. We could say, give me your auth token, and I'll set it as a cookie and ship it over to GitHub. Similarly bad, we have to store a plain text auth token. We can't hash that because we have to go back to the auth token to be able to send the request. So we have insecure storage of credentials, and just generally asking the user to trust us with their entire account is bad. This is the reason why we would have an API key to begin with, is so we don't have full access to the user's account. We can't go in and change their password with an API key, for example. So terrible idea. Okay, so let's move on to the API keys. We just learned what API keys are, so hopefully API keys can save us here. Let's have the user generate an API key and hand that API key over to us. And this is actually pretty close to the eventual answer that we're going to have. This is pretty close to good, but it has some issues. So let's talk about this bad idea for a while, because this is a little trickier to see why it's bad. The big one, at least for me, is the lack of accountability. If a user goes to the API, gets an API key, and hands it over to us, whenever we make a request using that API key to that server, to GitHub in our example, it looks like the end user made that request. They have no knowledge that we're involved, that we have an app that's acting on behalf of that user. They're instead just seeing, okay, I got a request to contain that key. That's the key I issued to this user. I looked their username up in the database. Okay, this must be that user. So there's no accountability for the app. If the app goes out of control, maybe even incidentally, you accidentally wrote an infinite loop or infinite recursion, and it fires off a ton of requests, and starts racking up a bill even if the API charges per access, all of a sudden your user is getting charged, and you're just like, well, I don't know. Nobody even knows it was you. GitHub is going to go, well, GitHub doesn't charge per access like that. But the API could go to your user and say, here's your bill. You made a ton of requests, and the user might not even know that it was your app that was irresponsible with the key. So lack of accountability, for me, is the biggest one. But there are other issues with this, too. But let's walk through why this is bad, and we'll start building our picture of what we're eventually going to do. This will be most of the picture when we go through this workflow, and then we'll add to it to get officially OAuth 2.0. Okay, so this is our structure. We have an app, and there's 3 different entities. If you read the RFC, there's at least five different entities. I'm going to roll the API, the auth server, and the resource server all into one. Actually, auth server and resource server make up the third-party API. But there's 3 different entities. And I'm going to start introducing the terminology here because OAuth, in my opinion, do I even have to qualify with this, is kind of needlessly complex and needlessly hard to understand. It's not too complex, but the way it's presented is awkward. The biggest thing that at least took me, maybe it is easy, maybe you'll read it and know what's going on, but the biggest thing for me that took me a while to understand, when they say client, they mean our app. If we're the app author, I'm going to say everything in context of our app. So this is our Scrum Board app, this would be GitHub, and this is our end user. When they say client, I always think of, well, I have a server, and my client connects to my server. But in the context of OAuth 2.0, the term client means our app. That's our server is the client. We're connecting to a third-party API, and the user or resource owner, they call it resource owner in the documentation. I'll say app and user because, I don't know, that just makes more sense. But it's client and resource owner in the documentation. And then auth server and resource server are both part of the third-party API. And there is a reason to separate those two, but we'll talk about that. I think Friday is when we'll finally get to any reason to have a separate auth server and resource server. Okay, so our app, well, and before this, the user using our app, having a good old time, and they get to the point where we need to access the GitHub API on their behalf. So they click create a new card, I want to start my Scrum board, connect it to this repo, and do all that good stuff. Okay, so our app goes, whoa, slow down, slow down, slow down. I need access to your GitHub information. So we're going to request an API key. We're going to say, hey, user, I'm going to need an API key if I'm going to do this for you. User says, yeah, no problem. Let me go talk to GitHub for a second. User's going to go to GitHub, get an API key issued to them for their account, and hand that key over to us. They're going to say, okay, don't worry, I went to GitHub, I got an API key, here's my API key. We say, cool. We go to GitHub, and we start accessing the API on their behalf. Now, this doesn't seem too bad, I don't think. Yeah. It would be up to the server, up to the API server, how long the API key is valid for. If they have it set to expire at a certain amount of time, they would have to get a new key each time it expires. But it generally shouldn't be a one-use thing. It'll be multiple use, but it'll time out at some point, which might be in the year 2050, depending on the API, how they have it configured. When we get to OAuth 2.0, like for the Spotify API, they expire in an hour, and we have to request a new token. So for our cases, it'll be an hour. So this doesn't seem too bad. One of the issues we already talked about, and for me it's the biggest one, is the accountability one. But there are 3 issues I'm going to mention here. One, the lack of accountability of the client. Our app has an API key that looks like the actual user's usage of the app. So every time we go to the app, every time we go to GitHub, it looks like the actual user, our user. There's no accountability for us. If we do something dumb with that, GitHub is going to be blaming the end user, not us. We are not, according to GitHub, according to the third-party API, we're not even in the picture. They issued an API key to this user, and then they started getting requests with that API key. What are they supposed to think? What's your server going to be coded to think? I see that API key, that's this user. That's what it's supposed to do. And there's no compromise detection here. If we're irresponsible with that API key, and somewhere in our app we store this key in plain text, which we have to. We store this in plain text. We have a SQL injection attack. That key is compromised. And another person, an attacker, is starting to use this API key. We have no way to detect that, and it just looks like legitimate usage from a user. And there's no accountability. It does go back to accountability, but there's no accountability for us to say that we're the ones who leaked that key. Because who knows? It could have been the user who leaked that key. We don't know. They're going to blame us. We're going to blame them. We're going to say, you must have not been careful with that key. Somebody leaked it, but we're never going to know who. And finally, the old never trust your users. The user is a big part of this process, which is always bad. We don't want to trust the user with anything. No, not even their own security. We barely trust them to make their own passwords, and that's about it. Like only because we don't have a better idea, except log in with GitHub. This kind of gets there, gets one step of the way. But the user is handling their own API key, so if they do compromise the key and they're trying to blame us, there really is no way to know. They might have just been really terrible about it. They might have wrote it on a Post-it note or something, and somebody compromised it. We'll never know. The user's handling their own API key. We don't like that. And more realistically, the user might have some infection, some malware, or something on their device that's grabbing that API key without them even knowing it. They might be doing something irresponsible with no knowledge, no way of ever knowing that they did something bad. But once upon a time, they downloaded something it's .exe, and they just double-click it. Well, now they have malware, and all bets are off. Once you download an executable and run it, by the way, there's no security anymore. Anything we talk about with the web, if you're willing to download an exe and run it, you're done. It's over. It's game over. Okay, so OAuth 2.0 to the rescue. Past halfway, but that's the problem. That's the setup. And half of the solution, to be honest. So the setup is we have an app. Users are going to use our app, and we want our app to be able to make API requests on behalf of our users in a secure way. That's what we want to do. OAuth 2.0 is going to let us do this securely. And that's what it is designed for. OAuth 2.0, if you ever heard anything else, they're wrong. OAuth 2.0 is designed for third-party API access. So there's three entities, the user, our app, and the third-party API. That's what OAuth 2.0 is designed for specifically. It is used for a lot more than that these days. And my guess, I'm speculating a little bit, but most APIs only use OAuth 2.0. I assume just so they only have to build one authentication method. They just build OAuth 2.0 and say we're done with it. And they stopped supporting just issuing API tokens to users, which is kind of frustrating because that was the way to access APIs. You go get your token, and you put that token in every request. Then you can write code that accesses an API. And it was nice and easy. You wanted to just play around with an API in an afternoon or something. It was really easy to get your access token and start playing with that API. Now it's OAuth 2.0 all the way, and there's a lot more setup, as you're going to see all week. It takes a week of lecture to talk about it all. Instead of just saying, oh, yeah, you get a token. It's just like auth tokens. That's how simple it could be. It's not that simple anymore because most APIs only support OAuth 2.0. So it's designed for third-party apps. So even if you want to make API requests on your own behalf, you usually have to go, these days anyway, for major APIs, you usually have to go through the OAuth 2.0 process anyway, even though you're the app and the user. It doesn't matter. You still have to go through the whole flow, the whole workflow. Okay, so enough of my opinions and stuff. Let's get into what this actually is. And OAuth 2.0 is going to fix those security issues we talked about with one simple adjustment to this, and then more adjustments when we get to Friday. I'll talk about some extra things we can sprinkle on top of this. But the big thing is we're going to use access tokens. So instead, they're effectively API keys, but in the world of OAuth 2.0, they got to use a different term, so they're called access tokens. We're going to use access tokens that our app is accountable for and that never touch the user's hands. That's our goal, is to get those two properties: accountability and cutting the user out of the whole thing. When we talk about OAuth 2.0 this week, I'm going to use the authorization code flow. There's multiple ways to use OAuth 2.0. Authorization code flow is this safe to say, the most popular one? But it's the one that's designed to solve exactly the problem we have. There are other flows that do simplify OAuth 2.0 a little bit. That doesn't get it quite as simple as just give me an API key, but is a little simpler than the full authorization code flow. But if you're looking up documentation or anything, authorization code flow specifically is what we're talking about here. And this is made when you have a private server that can keep secrets. We're going to get a secret value that we have to keep protected. We have to keep it secret. If we're able to do that, we should use the authorization code flow. If we're not able to do that, for example, you want to write a mobile app that has no server support. You want to just put your app on the App Store and not have to worry about, if I get 1 million users, I have to scale up my infrastructure to be 1 million users. So it's front-end only, client-side only. Then you can't keep any secrets. You would use a different flow, and the flow for that one would be the implicit grant flow, which cuts some of the steps out of the procedure. That is not allowed on your homework. It's not our use case. We can keep a secret. We have a secret server, so it's not our use case here. Before we can use OAuth 2.0, we have to register with the API. We have to register our app, which, again, is app and client are synonymous throughout this lecture. We have to register our client app. Here, yeah, I'll use both terms. With the third-party API. For your homework, this means going to Spotify, going to their actual their developer site, and registering an app, naming your app, and going through some configuration, whatever setup. You give it a description or whatever you want. But these are the key three key pieces of information during that step. The client ID, when you create an app, Spotify or any OAuth 2.0 API, is going to issue you a unique ID to identify your app. And this is public information. Everybody gets to know your client ID. The users will handle this ID. They'll be able to see it. Attackers will be able to see it. It's just public information. The client secret, which, as the name implies, is not public information. This must be kept secret. And this is a very high entropy random value. It's just like your auth tokens, same concept and everything. Just some big, long, random thing. Same with the ID, actually. Just big, long, random identifiers. And the client secret is effectively your password. The API is going to generate it for you. They're going to make sure it's nice and high entropy. But it's effectively your password, and it's going to be used to authenticate your app. Must be kept secret. If you cannot keep this secret, which would be a front-end only app that doesn't have any server backend, your server is effectively like the App Store or the Play Store. That's hosting your front end, sends your front end one time, and then steps out of the picture. You can't keep any secrets there because everything is in the hands of the end user. So you wouldn't use you would use a workflow that doesn't have a secret. You use the implicit grant workflow, there is no client secret because you're telling them, hey, I can't keep a secret, so don't even give me one. And then finally, the redirect URI. This is provided by you. This is the one piece of information you must give the API. For your homework, this is a very specific string. Make sure you copy that string exactly, http://localhost:8080/Spotify. Use exactly that for your homework. In general purposes for your development, this is any URL that the API is going to send your users to after they allow you to access the API on their behalf. This is where the API is going to send your user. And it must be a full URL, so we specify protocol, host, port, path. Everything has to be in there. Okay, now let's get to it. Here's our full workflow. We're going to go through this one step at a time, but this is our end goal. This is the end picture that we're building up to. So now, instead of just requesting an API token, we're going to request an authorization grant. I'm going to go to the user. The user says, okay, I'd like to create a Scrum board for my GitHub repo. Our app says the same thing. Whoa, slow down. I need access to the GitHub API. I need to be able to access that and create issues on your repo. So we're going to ask for authorization to be able to do that. And that's going to send the user to the third-party API, specifically to their auth server, and ask them. They're going to take what we gave them, take that to the API, and say, this app would like access to this API, and they want to make requests on my behalf. Then they're going to get something like this. You've seen these before. It's hard to navigate the internet without ever seeing one of these, not necessarily for Spotify, but for whatever. And the API is going to say, okay, I took a look at this request from the app. It looks like by their client ID, I know who this is. This is the music timer app, and they would like to access these pieces of information. You're going to specify what scopes this you want to access, and you're only going to have permission to access certain endpoints of the API based on what you requested, based on what your app requested, and the user will very clearly get to see exactly what's being requested in this step. We want nice transparency. We don't want our app just accessing something and the user's like, I didn't give you access to it. You're going to get very clear information as a user what the authorization request is specifically requesting. The server is going to respond, assuming the user clicked, yes, this is cool, I'm okay with this. The server is going to respond with an authorization grant, which is going to contain an authorization code. And that code is the thing we're really after. That's what we want from these first 4 steps. So that's going to contain an authorization code. The client's going to send that code to us. We're going to get that authorization code. The whole thing is the authorization grant, but it contains the code. That's the bit of information we really want. And the user's going to say, here, I talked to the API. You have permission to access this API on my behalf with the scopes that you asked for. Here's the code that the API gave me to give to you that grants this permission. We say, cool, thanks, user. And then we go with that grant, with that code, we take that back to the API, specifically the auth server in this case, and we trade that in for an access token. So the access token is the real thing that we want. That's what's going to let us access the API on the user's behalf. But we had to go through this authorization code step first. So we cache in the authorization code for an access token. We send our information to the auth server, and this is where we have to verify our identity. The user knows that it was our app they were given permission to, but the server needs to know that we are that app. So this is the step where we would send our client secret to the server and say, no, I really am this person. Here's that secret that you told me to not share with anybody. Here it is. And then the server goes, oh, cool. Yeah, I verify that you are who you say you are. And this is an auth token that I just issued to this user. So everything checks out here. And it's going to respond with the access token, the big, nice piece of information that we want. This will also often come with a refresh token. We'll talk about the difference on, not till Friday. I'm not even going to talk about that on Wednesday, unless I go on a tangent. The access token, and it's not required on your homework. So we get an access token, and this is the token that we can use to actually access the API on behalf of our users. We send this access token in with any requests that we want to send to the API. Now that we have the access token, the user clicks create an issue. We go, okay, cool. We take our access token and access the API with that token and say, here's my token. That token says, it's from me. It is this app acting on behalf of this user. So it gets our accountability because it issued this token. The server issued this token to our app, not to the user. The user never touched the access token, importantly, so we don't trust them with anything except the authorization grant. That authorization grant is garbage to anybody except us because we're the only ones with the client secret that is needed to cache that in for an access token. So we got our accountability. We cut the user out of any of the pertinent parts, any of the secret parts of the communication, which is the access token. The access token is powerful. That is linked to our app and our user. So if somebody steals the access token, they can start making requests on our user's behalf as us. So we definitely have to keep that secret for both of our sakes. But if that is compromised, they know who to come after. They're going to go after us because we obviously leaked that, not the user. The user had no part in it. So we get all the features that we want. We can make our third-party accesses. If this was a login with GitHub, login with Google, whatever it is, we're going to make one request to the server and say, so who is this anyway? They're going to give us their account details, and then with those details, we create an account for that user. Issue them an OAuth token, just like we would during regular login, but they logged in with a different service, and we get their username from that service. Hey, and we got through it. 2 minutes to spare. So that's the authorization code flow of OAuth 2.0. And it all makes sense, right? It's a lot. I understand that that's a lot. For what it's worth, Wednesday, our plan is to go through this again. We're not adding extra things to this on Wednesday. We're just going to fill in the details, which there are a lot of details. It'll probably take the full lecture on Wednesday. We're going to fill in the details of how this works, because I'm saying things like the API sends the user back to our app with an authorization code. How exactly does that work? That specific answer is going to be with a 302. It's going to redirect with a query string. But filling in all those details is Wednesday's job, so you can actually turn this into code. Because right now it's just a diagram that, how the hell would you code any of this without going through the Spotify documentation, which part of it is going to be, when you're doing these AOs, is going through the Spotify documentation, following the steps, and coding it up. I'm not going to fill in every single detail, but we're going to get to the protocol-specific details on Wednesday. Then there will be some Spotify-specific things that I'll leave up to read in the documentation. Yeah, they can steal the access token, but we shifted the responsibility to us and not to our user. We're not trusting our user anymore. We have to be responsible with it. And if we're not responsible, it's easy for the API to revoke our access. They can just shut down our app if we're not being responsible. And you'll get your credentials revoked and everything.